Hi guys, my name is Maulida Prasditya. I'm from 11 Science 6 and welcome to my channel. Okay, before I start this video, I want to show you about something. Here we go.
No, I'm not. Holy shit! Oh my god! Oh my god!
Try one more time. Oh, there we go.
Holy shit!
Wow, that's very scary, right? But the fact is that lightning is one of the natural phenomena. And now, I want to explain you about the process of lightning, but first you must to know about definition of explanation text. Explanation text is a text which explains the process related to forming of natural, social, cultural, or scientific phenomena. And now, I have some special video. Let's check it out.
Whether it's up in the sky during a thunderstorm or helping send a DeLorean back to the future, lightning is a beautiful, dangerous phenomenon. Most people picture lightning as a brilliant white strike that flashes between a cloud and the ground. But there's also lightning within clouds and between clouds. Plus, there's colored lightning and even glowing ball lightning. It's all about a buildup of electric charge and the release of that energy in a bright flash. To have a lightning strike, you first need to separate positive and negative charges within a cloud. Clouds are essentially a bunch of really small, dust-borne ice crystals and water molecules. During a storm, the air is moving around and making these particles collide. So one theory is that some negatively charged electrons from the upward-moving water molecules get transferred to the downward-moving heavier particles. This makes the bottom of the storm cloud more negatively charged and the top of the storm cloud more positively charged. And remember, like charges repel each other. So the electrons near the Earth's surface are repelled away, and the ground underneath the cloud is left with an overall positive charge. All this charge separation creates a strong electric field between the ground and the cloud. Basically, an electric field describes how much force and in what direction a positive charge would go if it were in the field, in this case, upward toward the cloud. And when the difference in charges builds up enough, the first stage of lightning begins. Most of the time, we see negative lightning. This is when the electric field grows strong enough that an invisible channel of negative charges, called a stepped leader, begins to branch toward the ground at about 50 meters per microsecond. Meanwhile, an upward-moving channel of positive charges, called a streamer, rises up. They meet with a huge, bright flash that travels up. Not to mention the heat, over 25,000 degrees Celsius, which is about 5 times hotter than the surface of the sun. Because the negatively charged electrons stream from the cloud down to the ground, it's called negative lightning. There's also the much less common positive lightning, with a net transfer of positive charge from the cloud to the ground instead. These strikes start at the top of a cloud where positive charges hang out, so they need to travel through much more air to reach the ground. So they need even more charge separation, which means the strikes can be up to 10 times stronger than negative lightning. In fact, these strikes can even break apart molecules in the atmosphere into ions, which can collide with other molecules like hydrogen and oxygen and cause photons of red light to be released. If this happens, we call them red sprites. They usually only last milliseconds and can kind of look like giant jellyfish in the sky. And if that sounds cool, there's another type of lightning called a blue jet. This lightning occurs when large amounts of positive charge stream upward in order to neutralize the charge in the cloud. The blue jets can get up to 40 kilometers high, but only last for fractions of a second. And scientists believe their blue color comes from ionized nitrogen molecules. Even weirder is ball lightning, a glowing grapefruit-sized ball of gas that lasts up to 20 seconds. But scientists aren't quite sure what causes it. One theory suggests that ball lightning is caused by ions made by a lightning strike near glass, like a window. The ions could pile up on one side of the glass and create an electric field, exciting air molecules on the other side, which would release photons and create a glow. Another theory suggests that elements in soil are to blame. In 2012, scientists in China recorded the first video of ball lightning. They monitored the light it emitted and and found that it contains silicon, iron, and calcium, which are all elements found in soil. So a cloud-to-ground lightning strike might vaporize the soil's silicate compounds, which react with the surrounding atmosphere to produce a ball of light. So, the next time you're watching a thunderstorm from the warm, dry safety of your home, remember that all this lightning has a lot of physics behind it. Beautiful, dangerous physics. Thanks for watching this episode of SciShow, brought to you by our patrons on Patreon. If you want to help support the show, just go to patreon.com/scishow, and don't forget to go to youtube.com/scishow and subscribe.
A lightning strike is no joke. It's a 300 kilovolt burst of energy that can heat the air around it to 27,000 degrees Celsius, which is about 5 times hotter than the surface of the freaking sun.